What lies at the outer reaches of the observable universe has been a captivating mystery, sparking intrigue and theories among both scientists and enthusiasts for centuries. Enter the James Webb Space Telescope, a technological marvel with the potential to unlock this cosmic enigma. Recently, it made a groundbreaking revelation about what exists at the farthest edges of our observable universe. To comprehend this, we need to grasp the concept of the observable universe, which encompasses all that we can currently see, measure, and explore from Earth or our space-based telescopes and probes. Ready to embark on a journey through the cosmos? Subscribe to Cosmic Discovery and join us as we unravel the secrets of the universe, one celestial revelation at a time. This observable universe includes stars, galaxies, and other celestial wonders within our observational grasp. Distinguishing between the universe at large and the observable universe, the latter is merely a fraction of the vast cosmic expanse that we can currently study. While the complete dimensions and structure of the entire universe remain unknown, we estimate the observable universe's diameter to be around 93 billion light-years. To put this in perspective, a light-year is a unit denoting the distance light travels in a year, roughly 5.88 trillion miles or 9.46 trillion kilometers. Therefore, the diameter of the observable universe, at 93 billion light-years, spans an incomprehensible distance of approximately 546.8 quadrillion miles or 878.5 quadrillion kilometers. This showcases the mind-boggling scale of our cosmic surroundings, a challenge to fully grasp. The question arises, why is the universe so astoundingly vast? The answer lies in its origins. According to the Big Bang Theory, approximately 13.8 billion years ago, the universe burst into existence through a powerful explosion. This event triggered a rapid expansion, a phenomenon that continues at an accelerating pace driven by mysterious forces like dark energy. As the universe expanded, gravitational forces caused particles of matter to cluster together, forming awe-inspiring structures such as stars, galaxies, and eventually even planets like our own Earth. Over countless eons, these cosmic structures evolved, growing larger and more intricate, resulting in the breathtaking diversity of objects and phenomena observed throughout the universe today. Despite its immense size, much of the universe remains predominantly empty. Let's put things into perspective. If we were to shrink our entire solar system down to the size of a quarter, the closest star would still be as far away as 2 soccer fields. And that's just within our Milky Way galaxy, which is just one of the billions in the vast observable universe. You might be wondering, why can't we see the whole universe? 2 factors explain this. Firstly, light takes time to travel through space. When we look at distant objects, we're actually seeing them as they were in the past. The farther an object is, the longer its light takes to reach us. So, when we observe distant galaxies, it's like peering back in time, unraveling the history of our cosmos. The second reason is the universe's expansion. Picture dots on an inflating balloon. As the balloon expands, the dots move apart. Similarly, galaxies in the universe are drifting away as space stretches. This causes the light from distant objects to become stretched too, shifting towards longer wavelengths that we perceive as redshift. As objects move beyond a certain distance, they eventually go beyond our observational reach. Taking these factors into account, it's not surprising that we haven't seen the entire universe. The concept of the edge of the universe has fascinated scientists, philosophers, and thinkers for ages. While there are various theories about what lies beyond, 3 stand out. The first theory suggests that the universe extends infinitely with no end in sight, based on the cosmological principle stating that the universe looks roughly the same in every direction. This implies an endless universe without a boundary. The second theory proposes that the universe is finite, but lacks a clear edge. It's like a giant ball, where if you keep going in any direction, you'll eventually loop back to where you started. The third theory is the multiverse theory, suggesting that our universe is just one of many. Envision a multitude of parallel universes, each with its own rules and properties. These cosmic realms may exist independently or be intricately linked. We've delved into various theories about the universe's edge, exploring intriguing concepts. Now, let's shift our focus to a remarkable tool poised to unravel these mysteries: the James Webb Space Telescope. This extraordinary telescope enables us to peer deep into the past, unveiling surprises from the early cosmos. Thanks to the West's technological prowess, astronomers have gazed back into the universe's infancy, unearthing the unexpected. A recent study in Nature by the GWC team disclosed 6 colossal galaxies dating back 500 million to 700 million years post-Big Bang. Initially anticipating small, nascent galaxies, researchers were astonished by the GWC's revelation. These galaxies defy prior expectations, challenging our understanding of the early cosmos. But there's more. Researchers made a staggering observation. These galaxies are as mature as our 13 billion-year-old Milky Way. The massive stars within each surpass our Sun by several billion times, a revelation showcased in the research. Remarkably, one of these galaxies may be a staggering 100 billion times the mass of our Sun. To put it in perspective, our Milky Way hosts stars equivalent to about 60 billion suns. The JWST's unique ability to detect infrared light unveils the faint glow of ancient stars and galaxies previously invisible to us. This capability essentially transports us back in time, offering a glimpse of the universe around 13.5 billion years ago. Now, here's the captivating twist. The universe is estimated to be 13.7 billion years old. This discovery disrupts our understanding, akin to rewriting the history books. These colossal galaxies, playfully dubbed universe breakers, have left scientists perplexed. They challenge 99% of our earlier models for early galaxies, debunking the notion that galaxies started as small stellar clouds gradually expanding. The revelation of the Webb data and high-resolution telescope photos in July 2022 left researchers in awe. Seeing these galaxies as significant points of light, they found themselves questioning their own interpretations of the data. The unexpected emergence of these immense cosmic entities, almost as if they wanted to be discovered, astonished everyone. As scientists utilized spectroscopic methods to analyze light across various wavelengths. This technique unveils crucial details about these galaxies, including their composition, size, and distance from Earth. What's truly captivating is that this groundbreaking revelation wasn't even at the forefront of scientists' expectations for the James Webb Telescope. It not only surpassed all projections, but also unfolded much more rapidly than anticipated. There's even a chance that some of the objects identified through Webb data might be something entirely unexpected. While most are likely galaxies, a few could potentially be elusive supermassive black holes. Here's the intriguing twist. The known mass of stars in the universe is now believed to be up to 100 times greater than previously thought. This discovery remains mind-boggling, even when considering only half of the sample. Simultaneously, utilizing the potent James Webb Space Telescope, an international team of astronomers led by Jay West made another remarkable discovery. They identified the oldest and farthest galaxies ever confirmed. These galaxies transport us back to a time when the universe was just a fraction of its present age. Less than 400 million years after the Big Bang, the light from these galaxies reached us. This event occurred more than 13.4 billion years ago, as detected by the telescope. Similar to early observations by the Hubble Space Telescope, the initial images captured by the JWS team revealed numerous potential galaxies. Now, through careful spectroscopic observations, astronomers have verified 4 of these objects. This not only enables the study of the physical properties of the galaxies, but also accurately determines their distances, a crucial factor in understanding a galaxy's position. Astronomers gauge a galaxy's distance by calculating its redshift. If you're wondering what redshift is, it turns out that as the universe expands, objects seem to move away from us, causing their light to stretch and shift toward longer, redder wavelengths, a phenomenon known as the Doppler effect. While redshift estimates can be obtained from photos taken through various filters, spectroscopy is the preferred method for precise measurements, breaking down the object's light into its constituent wavelengths. The recent discoveries center around 4 galaxies with redshifts greater than 10, indicating their significant distance. The Hubble Space Telescope had previously spotted 2 of these galaxies, with confirmed redshifts of 10.3, 8, and 11.58. However, the JW estimate has unveiled even more distant galaxies, with redshifts of 13.20 and 12.63. A redshift of 13.2 signifies a time roughly 13.5 billion years ago, offering a glimpse into ancient cosmic history. Furthermore, there's an exciting initiative known as the JWST Advanced Deep Extragalactic Survey, or Jades, which has been granted over a month's worth of time on the telescope. The main goal of this ambitious program is to offer an unparalleled, in-depth look into the early cosmos. Back in 2015, a collaboration of instrument teams pitched this project, forming an international partnership named Jades. This group consists of more than 80 astronomers and scientists from 10 different countries, spearheaded by NIRCom. The Jades program specifically allocated more than 10 days to observe a small section of the sky, which includes the Hubble Ultra-Deep Field. For over 2 decades, astronomers have been scrutinizing this area using various large telescopes, studying it across 9 different infrared wavelength bands. The Jades team, during this dedicated time, made an astounding discovery: nearly 100,000 distant galaxies, each billions of light years away. Subsequently, employing the near-spec spectrograph, scientists gathered light from 250 faint galaxies over a 3-day observation period. This allowed them to unveil the characteristics of the gas and stars within these galaxies, obtaining precise redshift values. With these measurements, astronomers can determine the intrinsic brightness of the galaxies and estimate the number of stars they contain. This comprehensive approach enables a detailed examination of galaxy formation over time, even without direct knowledge of their early growth stages. Studying galaxies is as intricate as understanding human beings. The early generations of stars wield a significant influence on the future of galaxies, much like our early experiences shape our lives. We are currently in a remarkable era where the transformative capabilities of the Webb Telescope are addressing numerous questions about galaxies. NASA's Deep Space Observatory Telescope is reshaping our comprehension of the cosmos and revealing a trove of new discoveries. The James Webb Space Telescope, or Webb, is a trailblazer in scientific research, providing us with astonishing insights into galaxies, planets, stars, and other captivating cosmic phenomena. Launched in December 2021 and expected to function for 2 decades, Webb is just embarking on its cosmic adventure, surpassing the standard set by its predecessor, the Hubble Space Telescope. Webb has captured the imagination of scientists and the public alike, sparking a wave of scientific enthusiasm. People worldwide are eagerly processing the telescope's raw data, sharing its breathtaking photos, and gaining fresh perspectives following a flawless deployment process. Webb amazed us with its initial photographs in mid-July, granting us an unprecedented view of our universe's myriad aspects. With the help of its advanced infrared telescope, we can explore the farthest galaxies in remarkable detail and peer into the depths of the past. Just a few days after launching in late June 2022, the James Webb Space Telescope began uncovering a treasure trove of cosmic secrets. It swiftly revealed thousands of galaxies, previously unknown, that are both older and farther away than we ever imagined. The telescope's powerful instruments allowed scientists to capture ample light from celestial wonders like exoplanets and newborn stars. This not only unveiled their compositions but also traced their journeys through space. Already, this wealth of data is painting a detailed picture of the atmospheres of planets located hundreds of light years away, giving us tantalizing clues about their potential habitability. But the excitement doesn't stop there. By examining faint traces of light from the universe's early days, the James Webb Space Telescope has potentially pinpointed the oldest black hole ever observed. This supermassive black hole, with a mass 9 million times that of the Sun, resides at the core of a young galaxy that formed just 570 million years after the birth of the universe. Thanks to Webb's impressive cameras, capable of peering back in time to the cosmos's earliest moments, this groundbreaking discovery provides insights into the cosmic dawn. It reveals when numerous black holes grew in size over 1 billion years following the Big Bang. The origins and proliferation of these mysterious cosmic entities have long puzzled astronomers. Some of these colossal disruptions emit light observable by telescopes, generated by the friction of material spiraling into their gravitational abyss. These entities, known as active galactic nuclei, encompass supermassive black holes or quasars, each billions of times more massive than the Sun. They emit intense bursts of light, trillions of times brighter than the brightest stars, representing the most extreme form of cosmic phenomena. As scientists delve deeper into the cosmos, they can capture light from more distant sources, offering glimpses into earlier stages of the universe. The James Webb Space Telescope uses its mid-infrared instrument and near-infrared camera to scan the sky for black holes. Its built-in spectrographs then break down the light spectrum into different frequencies, enabling scientists to analyze the data during their investigations. In a pivotal discovery, scientists found that the heated material surrounding a black hole emitted faint traces of radiation across the universe. By scrutinizing these delicate signals from the universe's infancy, they identified an unexpected surge among the frequencies embedded within the light, providing valuable insights into the cosmic processes at play. The rapid appearance of black holes in our young cosmos remains a mystery, prompting scientists to continue their search for much younger primordial black holes, believed to have formed right after the Big Bang, or possibly even earlier. Yet, these elusive objects have not yet been found. Meanwhile, two main explanations exist for the abundance of black holes in the present universe. One possibility is that they are remnants of massive stars that formed much more rapidly than the stars we observe today. Alternatively, it's suggested that dense clouds of gas suddenly collapsed to form these enigmatic singularities in space-time. A more likely scenario involves a trio of stars within a population 3 classification, a speculative star type that appeared roughly 200 million years post-Big Bang. These stars were mainly made up of hydrogen and helium. One of these stars would have exploded, leaving in its wake a black hole. Over time, this black hole would have expanded by rapidly accumulating matter at an unsustainable rate. Scientists are teaming up with the developers of the Jades Project to investigate the light from distant galaxies, hoping to uncover more clues about the mysterious black hole at the heart of one such galaxy. Researchers have also delved into the early stages of the universe, witnessing the formation of a protocluster consisting of 7 interacting galaxies. This cluster, identified by the Hubble Space Telescope, is the farthest galaxy cluster pinpointed to date. Simulations suggest it will eventually evolve into one of the oldest and largest galaxy clusters in the universe, boasting a mass nearly 100 times greater than our Milky Way galaxy. While the Hubble Space Telescope initially discovered these galaxies, it lacked the precision to measure the exact distances between them, despite their alignment along the same line of sight. Picture being high above Los Angeles, looking through a telescope. You enter the James Webb Telescope, providing us with a much clearer view. According to scientists, these clusters are exceptionally rare and hard to find, and while it's improbable that the GWC will stumble upon another unique system like this, the upcoming Nancy Grace Roman Space Telescope, scheduled for an early 2027 launch, will significantly boost our capacity to identify galaxy clusters in the early universe. Its extensive survey capabilities will outshine the JWT by more than 100 times. Back in the 1990s, astronomers using the GWC made groundbreaking exoplanet discoveries. Thanks to this innovative telescope, we now know of over 3,000 extrasolar planets, although only a dozen have been directly captured on camera. Most exoplanets are so distant that we can only observe them when they pass in front of their host stars, causing a slight dimming of light. However, the GWC has transformed the game with the telescope's coronagraph. Coupled with its cameras, filters, and other equipment, scientists can directly observe exoplanets. In 2017, the Sphere Consortium made a significant discovery by identifying a planet called HIP 65426b using the Spectral Polar, a metric high-contrast exoplanet research instrument chip. In September 2022, it gained further attention as the first exoplanet directly observed by the James Webb Space Telescope. What makes this planet particularly intriguing is its unique characteristics, combined with the remarkable sensitivity of the James Webb Telescope, allowing for easier observation. Unlike any other planet in our solar system, HIP 65426b is positioned at a distance from its host star that is 100 times greater than the distance between our Sun and Earth. To put things into perspective, consider this. Pluto is just 40 times farther from the Sun than Earth. Now picture an exoplanet, a massive gas giant that's a whopping 12 times larger than Jupiter. Even though the phantom galaxy may be elusive in the night sky, its brilliance becomes apparent, especially when captured by Webb's infrared camera. When we gaze at the galaxy known as M74, we're treated to a breathtaking view of its exquisite spiral shape and the scattering of stars. The radiant center of the galaxy gives rise to arms that extend outward, and Hubble's optical perspective showcases its grandeur, revealing structures resembling heat-emitting dust and gas fibers emanating from a bright center, all presented in a stunning electric blue. Meanwhile, in the image captured by Webb, we witness the illumination of star-forming regions scattered across the spiral arms. Thanks to its infrared capabilities, a mesmerizing composite image has been crafted by combining photos from the Hubble Space Telescope and Webb. This composite accentuates both the optical and infrared views of the galaxy, providing a more comprehensive understanding. Featured in an international project, these three images were incorporated into a film, allowing astronomers to compare them side by side. This process enabled them to pinpoint regions where stars are currently forming and calculate precise measurements of star cluster masses and ages. Additionally, Webb's studies have yielded valuable insights into the characteristics of tiny dust particles traversing the vast expanse of interstellar space. Webb also captured an image of a distant Wolf-Red star, WWR 140, displaying a distinctive diffraction pattern. Surrounded by a ripple-like arrangement of concentric rings, this star takes on an oddly boxy shape. Remarkably, these distinct ring formations are not mere imaging artifacts, but actual features of the star. These massive stars, nearing the end of their lifespan, have released a significant amount of hydrogen into space. The interaction between WR 140 and its small companion star shapes a cloud of dust into the form of their neighboring star, resulting in the peculiar shapes of the rings in the constellation Virgo. The most extensively studied exoplanet outside our solar system orbits a star. This planet, named Wasp 39b, resides an astounding 700 light-years away from Earth. It's a scorching gas giant, comparable in size to Saturn, orbiting its host star at an incredibly close distance, roughly 8 times nearer than Mercury is to the Sun. In the end, Webb was designed to explore the farthest reaches of the universe, and and researchers have confirmed its success in doing just that.